In this video, I'm going to read this passage again, but I'm going to annotate as I go. So it won't flow like it should when you read. That's why I wanted to do the first reading, just to let you listen and read along if you want. But in this exercise, we are going to annotate this passage, and I'll show you what that means. I'm going to use highlighters to annotate. Now, as I look at this, I see some pictures. I see some words in bold. And then on this page, I actually see some questions at the bottom. So just glancing at this text, those are the things that stand out to me. I also see the chapter title, Nature of Science, and the lesson title, The Method of Science. So those pieces are going to be important a little bit later on. But as I start to read here, I see a middle school or high school student. She's wearing gloves, she's wearing goggles, and it looks like she's conducting some sort of experiment. Okay, the first thing I see is the word science, and that is in bold. So I'm going to just put a box around that. And the next word I see is the word is. So that tells me that a definition is coming up. So I'm going to highlight right here, and then I'm going to highlight the definition. Science is a process that uses observation and investigation to gain knowledge about events in nature. This will happen on tests a lot. Your test question may say, "What is science?" And if you know this trick, you can look back in the passage and find that answer. You don't even have to wonder about it. It's right there. It is stated for me. Okay, reading on, it says that it, meaning science, is based on logic and evidence with the goal of providing explanations and understanding. There's a mistake here. We need to take off that S right there. Understanding patterns about how and why things happen. Scientists then use the information or knowledge gained to make predictions about future occurrences. Science covers three main categories. I'm going to add those to my definition. Anytime I see a number like I do right here, I want to annotate that. I want to take notice of that number. And then I should be able to find those three things. Let me make a little bit smaller lead. So there's 1, 2, and 3. This will help me comprehend what I'm reading if I practice these tricks. When scientists pose a question or design an experiment, they follow an organized set of investigative procedures called the scientific method. So here's another vocabulary word that I need to mark. And I like to put a box around those just for my own knowledge. And I'm looking for a definition here. Okay, now we don't have the word is, but we have a definition in front of this box. It is an organized set of investigative procedures. So you see the definition in this case before the actual term. The scientific method has distinct steps. And then I see one of my favorite words in all the world, and that is the word first. This is a sequence that is starting off here. So first, what's the first step? An observation is made that leads to a question about how or why something occurs. After asking the question, so here's the next step in my sequence. There's the word hypothesis, that is in bold. So let's take that one and find the definition. And this one doesn't have the word is, but it says hypothesis, comma, or educated guess or testable prediction. There is my definition of hypothesis. So this author is defining the vocabulary for me if I just know where to look. Then I have another sequence word. I have next. And I have another vocabulary word, that is experiments. Now be careful with this one. It says an experiment is conducted that includes an organized and detailed procedure for testing the hypothesis. So an experiment is a procedure for testing the hypothesis. It is an organized and detailed procedure for testing the hypothesis. Now, I don't have the word next or then because it's still talking about experiments. When conducting an experiment, a control, there's a new vocabulary word. So a control is part of an experiment. What is a control? It's a standard for comparison. And we're going to look at examples of these and break them down. Right now, let's just get the definitions and then we'll work with what they actually mean. If there are too many variables changed in an experiment, then researchers aren't able to discern which variable is responsible for any results they may get. A constant. Here's another vocab. I know that because it's in bold. Is a factor that doesn't vary in an experiment. The independent variable is a factor that is adjusted by the experimenter, and it's found on the x-axis when graphing the data. And don't worry about that. Let's just get the definition. I'm going to explain all of this to you. The dependent variable, so here's another vocabulary word to highlight. This is part of annotating. Is a factor with a value that depends on the independent variable, and it's found on the y-axis. Now here's another sequence word. Finally, that's the same as saying at the end, the last step. The data is collected and analyzed and conclusions are drawn. Now, I'm not going to read all of this again because we've done that, but what I am going to do is highlight these arrows. These arrows are important. Anytime you see arrows in a passage, and I can't really see that color, so let me change it just a little bit. So let's highlight these arrows. We're going to use these a little bit later. Let me see if I can't get that straight. Evidently not. I'm drawing a straight line. That's not working too well, is it? But let me go ahead and highlight those anyway. There we go. Just notice anytime you have arrows in a diagram. That's all I'm pointing out to you here. And I am annotating those so that I'll make sure I don't overlook them. And these are complicated. They're going in all directions here. Okay. So we'll take a look at this a little later when we do our graphic organizer for this lesson. But let's go ahead and highlight the arrows just so we don't forget about them. And then moving on, evidence from research leads scientists to propose scientific theories. There's another vocab word, so I'll highlight that one in yellow. I'm using yellow for definitions. And let's see if we can find the definition of a scientific theory. That word "or" is really nice because that's telling me the definition will follow. Scientific theories are explanations based on experiments. A scientific theory is a logical explanation that is based on data. It is not a guess. For example, when you are playing the game Clue, you might say, I have a theory that Colonel Mustard killed Mrs. Peacock in the study with the wrench. When a scientist talks about a theory, like the black hole theory, they are referring to a well-tested explanation based on observations. So all of that relates to that definition of scientific theory: observations, research, and data. And then I have a new vocabulary word. Scientific law is a rule of nature that sums up all the related observations to describe a pattern in nature. And here's the important part: it is true all the time. The law of gravity is a scientific law. So we have read this passage and we have annotated. You see how when I'm annotating, the passage doesn't flow. It's not as easy to understand. I'm really picking it apart for details. And I got a lot of definitions. I got some sequence words like first and after and next and finally. And then I have these little boxes with the arrows. Those are important. And some more sequence words. So I have annotated this passage. I'm going to do one more thing because I want to make sure that I'm calling your attention to this. So let me get orange. And I'm going to highlight the name of the chapter, which is Nature of Science, and the name of the section. And we will be using that as well. So we have picked this passage apart, and in the next video, we will apply this knowledge to some other things.